Okay, so what I think I'll do is just start at 3.1, just kind of go through the sections and just review, maybe do some practice, some sample problems. I want to start 3.3 today, so we'll get through 3.1, 3.2 just to review, do a couple problems, and then I'll talk about 3.3. And I think 3.1 and 3.2 are both open still through tonight. So if I need to extend that to tomorrow night, just tell me. That's no big deal.
I appreciate it.
Okay. So 3.1, the fundamental
We're
identities.
still in 2018.
Oh, it is?
I can see the 3.2.
You can't get it? Okay. I'll get it open for you. Okay.
Yeah, I saw that yesterday. It's in November 6th, 2018. And I was
Oh,
well, it's a little bit.
sweet. Okay. All right. So we have just your normal sine, cosine, tangent that are opposite over adjacent, or opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So tangent, the first quotient identity is that tangent is equal to sine over cosine. Okay. Let's see what the next. Then we have cotangent is cosine over sine, cosecant 1 over sine, secant 1 over cosine. Okay, so those are your just regular reciprocal identities, and I think those are all, I don't even know if they're on there. Yeah, they're all on there. Okay, so that should be somewhat of a review. Then you get to your Pythagorean identities. And the reason that, well, let's just do sine theta is y, right? In the unit circle. If this is, right, 1, 0, and 0, 1, and I draw where this is 1, right? This is y, this is x. So sine is equal to y over 1, and x is equal to, or cosine is equal to x over 1. So we know these two. So I also know x squared plus y squared equals 1 in this triangle. Okay, so that means that cosine squared plus sine squared theta. Okay, so the reciprocal?
Or not the reciprocal.
The other?
Yeah, like
Okay, so I can do one of two things. I'm going to go ahead and just divide here. I'm going to divide both sides. I'm going to divide this by cosine squared. I'm just dividing by the same thing all the way across. So this becomes 1. What's sine squared over cosine squared? And what's 1 over cosine squared?
I get it.
Mind blown, right?
So you have to turn it into that.
Okay, so then I can also,
Yeah.
if I start with this, divide everything by sine squared. I get 1 plus cotangent squared cosecant squared.
Okay. Be comfortable.
Yeah.
Not doing it right.
Okay, so I've proven all three of these then.
Yes.
Yes.
Cofunction.
Yes. Quotient, we already know. We talked about those after reciprocal just a minute ago. Tangent, sine over cosine. Cotangent, cosine over sine. I think that's all that you need for 1 and 2 at least. Let me go and see here.
Cofunction is basically just shifting it.
Yeah. No, we do talk about, well, we talked about that in chapter 1, what the
Yeah.
cofunction identities were. And it does. It just shifts it pi over 2, you know, or you think about the unit circle and you move it into the next quadrant and how those are related. So those are your cofunction.
If you move it pi over 2, the sine becomes cosine and all that
Right,
stuff. But if
right.
you just move it pi,
Then I put the videos at the end for 3-1. So
it's just basic.
let's go to section. So 3-1 is kind of introducing those identities, and then 3-2 is actually performing proofs. And they're not really proofs like we learned in geometry.
Thank God.
I know. They're just trying to get the one side of the equation equal to the other. And I'll show you what I mean by doing one here.
We all love some geometric proofs, all right?
Yes, I love them.
Who created them? Who thought that was a good idea?
Let me find a,
Who thought P equals Q? But what if it doesn't?
let's see if I can find, oh, stop. So this one, prove the identity 1 plus tangent theta over 1 plus cotangent theta equals tangent theta. Okay, so usually with these proofs, and in fact, if you go to the very first page of the section, I put on there, well, they're right here too. Work on one side of the identity, so don't try and work both sides. Just work on one, trying to get it to match to the other. Try rewriting all expressions in terms of sine and cosine. If there are fractions involved, combine them. If you can reduce it, reduce it. And the other piece of advice would be start with the, if you're going to pick which side to start with the more complicated side, not the easier side. Okay. So what I'm trying to do is get this side to equal this side. So I'm not going to mess with this one. That's going to be tangent theta all the way down. I'm just going to work on this one. Okay. So in the numerator, I'm going to get everything converted. Agree so far? Okay, and that's equal to tangent theta. I'm not changing the right side. I'm just going to bring it down as I go. Okay, now in the numerator, I'm going to get a common denominator. We good there? Do you notice, did you see how I got the common denominator? Everybody follow? In order to get cosine in both terms, I multiplied this by cosine. To get cosine plus sine divided by cosine, so I have a common denominator. I did the same thing here. Okay? This is equal to tangent. Well, when I have a fraction and I divide it by a fraction, when I divide a fraction by a fraction, it's the same as multiplying by the reciprocal. Right? So this is the same as the reciprocal. Still with me? Just flipped it, multiplied. Flipped this. Multiplied. Okay, now, is cosine theta plus sine theta the same as sine theta plus cosine theta?
Yes.
Yes, commutative property says I can do that. That becomes 1. And sine over cosine is tangent. They're just puzzles.
Yeah.
That's all they
There's
are.
a lot of rearranging.
Rewriting sine and cosine. Let's see if I can find another example. Let's do one in the book. Sine theta over 1 plus cosine theta. Plus, I think it was 1 plus cosine theta or sine theta. but I don't remember exactly. Come on. Yes, and it's equal to 2 cosecant theta. Come on. Okay, so I need a common denominator. It's going to be this times this, right? So I'm going to multiply this, I get sine squared. Multiply these together. Be careful, there's a middle term. 1 plus 2 cosine theta plus cosine squared theta. And that's all over 1 plus cosine theta times sine theta. With me? You guys see that? 2 cosine theta, my middle term. Remember how you get it? This times 1, or 2. This times 2. Okay. What is sine squared plus cosine squared? 1, right? Plus 1 plus 2 cosine theta, right? Over 1 plus cosine theta okay, so 2 plus 2, factor out of 2, 1 plus cosine theta, right? Divided by 1 plus cosine theta times sine theta equals 2 cosecant. Cosecant. This cancels.
So
2 over sine theta, which is 2 cosecant theta.
So it's just a lot of rearranging.
Yeah.
Yep.
Okay.
Okay. All right,
Because
so
it's so much longer.
the next section, which I realized, do you want me to just do 3-3 tomorrow? Let you guys work on 3-2 today?
I'd be very
Since it's not
thankful
open
for
yet?
that. Yeah.
Okay, we'll just do that.